Greetings and salutations. Today's lesson is lesson 80, and it is prime and composite numbers. Prime and composite numbers. Now, these are terms that you will see a lot. You need to make sure you understand them. But once you have them down, you can do the math, and some of our divisibility rules can help you. But it's just really something you need to be able to either have memorized or be able to figure out. And either way, it's not very complicated. So let's look today at lesson 80, prime and composite numbers. Okay, the first thing we need to do is get down some terms. So a prime number has exactly two factors. And then put in parentheses 1 and itself. That means I can only multiply a number by itself and get the answer. For example, 2. The only way I can get 2 is to say 2 times 1, let's try that again. 2 times 1 or 1 times 2. So, sorry about that. Okay, so that's the only way I can get 2. Now, if I say 3, well, I can multiply 3 times 1 or 1 times 3. There's no other number that goes evenly into 3. So those both are examples of prime numbers. Now, next, go ahead and put composite numbers. Composite numbers have more than 2 factors. Composite numbers have more than 2 factors. Now, you can see 2 and 3 are prime numbers. Now, let's take a look at a couple of other numbers so you have a contrast with prime numbers to composite numbers. Okay, now that you've got them in your head, I'm going to go ahead and put them right up here. 2 is prime because I can only multiply 1 times 2 and 2 times 1. 3 is prime because 1 goes into 3 and 3 goes into 3. There's no other numbers that go evenly into 3. 4 would be a composite. What can I multiply together to get 4? Well, I have 1 times 4, but I also have 2 times 2. So I have more than 2 factors. Now, when you would list out your factors, what you want to kind of get in the habit of doing is just listing them like we would normally list factors. 1, 2, 4. Whereas with this, it's 1, 3. Here, 1, 2. All right, if I go to 5, think in your head, what do you think it is, prime or composite? Hopefully your head said prime. The only 2 numbers I can multiply together are 1 and 5. No other number goes evenly into 5. 6. What is it? Hopefully you said 6 is composite. And here's why. I can multiply 1 times 6. I can also multiply 2 times 3. I have more than 2 factors. Now, honestly, the minute you get your second factor, you're done. You don't have to, with primes and composites, list them all out. As soon as I say the number, if I can think of a factor that goes in there, I'm done. So, for example, let me just write it down, and I won't write it in one of our 2 colors, but if I say 8, well, I know 1 and 8. That's all numbers. 2 goes into it evenly. Well, voila, it's a composite number. How about 7? Well, nothing goes into 7 except 1 and 7, so I know I'm done. It's a prime. How about 362? Well, hopefully you right away said, oh, wait a minute, it's an even number. Even numbers are divisible by 2, so any even number has to be a composite number, except for 2. 2 is the only even number. The 2 by itself, like up here, is the only even number that's not a composite number. So as soon as I knew that 2 went into it, well, it's no longer a prime. So you kind of have to be able to say right away what can go into it. Now that's where your divisibility rules can come into handy, where if you add up the digits, like for 3, you add up your digits. If that's divisible by 3, then the whole thing's divisible by 3. So you'd know how to identify prime, only having factors of 1 in itself. Know how to identify composites. They have any more than 2 factors, and they are automatically composite. And then sometimes your divisibility rules can help you out with that as well. So, again, be familiar with it. I do want to show you one more thing that the book talks about, and that is using an array to help you figure out prime or composite. Now, this is not something that you're going to use all the time, but it definitely can be of help sometimes, and since the book talks about it, I will really quick. Let's use the number 7. Right away you should know that that's going to be a composite number. I mean a prime number. 1, 2, 3, 4, 5, 6, 7. Can I put those in any shape where I'm going to have the same number in the top row and the bottom row, or in all the rows together? Well, what if I tried 3? 1, 2, 3, 4, 5, 6, 7. Nope, that doesn't work. How about rows of 2? 1, 2, 3, 4, 5, 6, 7. Nope, that doesn't work. So 7, there is no array that you can work where it will be evenly in all of the rows. So that is why 7 is a prime number. Now if I go 8, so I have 1, 2, 3, 4, 5, 6, 7, 8. Oh, I could do 1, 2, 3, 4, 5, 6, 7, 8. And look, they all are evenly, unlike right up here where they weren't even. Now I can also do, 1, 2, 3, 4, 5, 6, 7, 8. So I can arrange 8 in ways where I have the same in each set. So I know that 8 is a composite number because 7 couldn't do it. I could only lay it out this way. 8, I could do here, I could do it here, I could do it here. 8 is therefore a composite number because the array will turn out rectangular. Completely rectangular, same number in each row and for the columns down or the rows across. So that's just what the book talks a little bit about with showing prime and composite numbers. So that's it for today. Make sure you know how to determine the difference between prime numbers and composite numbers, and have a wonderful afternoon.